We're starting a whole new unit called Solving Systems of Linear Equations. Now I know your first question is going to be, what the heck is a linear system? Well, a linear system is when you have not one, but two or more equations that share the same variables. So in my example, I've given you two equations that have both an x and a y. So we could consider these a system of equation. Now, what I'm looking for is an x and a y value that, if I put them back into these equations, would make both of the equations true. That is called the solution to the system. Now, I could also graph both of these equations and their lines would intersect. And interestingly enough, they intersect right at the point where the x and y value make both of these equations true. Now, I've already done the work on this, and the solution to this system of equations that I have given you is the point 5, 20. So if I put the x value of 5 and the y value of 20 in both of these equations, I would get a true statement. And I'm going to do that real quick for you so you can see what I'm talking about. As you can see, I took the 20 and replaced the y, and I took the 5 and replaced the x in both equations and then solved them. And I got 20 equals 20. So indeed, 5, 20 is the x and y value that is the solution to this system of equations. Okay, now what we're going to learn is that there are several ways to solve a system of equations. One of the ways is graphing. Actually graph the lines and see where they intersect. Another way is to use algebra, and there's two ways to do that. There's a process called substitution, and there is a process called elimination, and we're going to learn all three of these ways over the next several weeks. The first thing that we are going to look at is graphing. Now, when you are using graphing to solve a system of equations, the first thing that you are going to do is graph both equations. Then you're going to look at your graph, see where the two lines intersect, and you're going to estimate that point of intersection. And then you're going to put that x and y value back into your equations, just like I did, to see if it is indeed the solution to the system. Before we get going on this, though, I want to do just a very fast review of graphing in general. All right, so when you have an equation and you want to graph it, the first thing you're going to do is make sure it's in slope-intercept form. And all the equations that you are going to do first will be in slope-intercept form. Remember, that is y equals mx plus b. And you are going to identify two things. That is the y-intercept, which is your b value out here. So in this particular equation, it is -1. You're always going to pick up the sign in front of the number. So my y-intercept of this equation is 0, -1. And then you're going to pick up or identify your slope, which is the value in front of your x, your m value. So in this case, it is 2. Now remember, slope when you're graphing is rise over run. So if I have a whole number, I'm going to put it over 1 to change it into rise over run. And I'm going to give myself some driving directions. The +2 on top tells me that I need to go up instead of down. The +1 on the bottom tells me I need to go to the right, because rise is up or down and run is left or right. Now, I am going to, oh, sorry, my cat just walked across my video screen, so hang on just a second. Okay, all's good. I'm going to go over here and I'm going to use my y-intercept. That's my starting point. So I'm going to make one nice big fat dot at 0, -1. And then I'm going to use my driving directions and my slope. From that -1, I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And I'm going to do that as many times as I need to make a really good line. Now remember, critical, critical, critical. You need to make sure that you are using a straight edge. This is especially important when we get into solving systems. So I'm going to use a straight edge and I'm going to draw the line. So that's just a quick review of graphing an equation. Now, let's look at solving a system by graphing. Oh, well, that didn't work well, did it? Let's see if I can try this again. Cece, get away. All right. I would like you to solve this linear system. And what we're going to do is we're going to graph each one of these lines. And then we're going to see where they intersect and check using algebra to see if that's the solution. So let's do our first equation here. Now remember, I'm going to identify the y-intercept and the slope. Okay, so on my first equation, I'm looking up here, and my y-intercept is -7. So I'm going to plot a point at 0, -7. Nice big fat point. And then I'm going to go over here and I'm going to identify my slope. Now, there's a 1 in front of that lonely variable, even though we don't write it down. So my slope is going to be 1, and I'm going to change that into a fraction, 1 over 1, and I'm going to put some driving directions. I'm going to go up 1 and to the right 1. So from my point, -7, I'm going to go up 1 to the right 1, up 1 to the right 1, as many times as I need to make a really good line. Now, I'm going to look at my next equation. -1/4 x minus 2. My y-intercept on this one is 0, -2. You look right here. And my slope is -1/4. Now notice that I put my negative with my 1. I'm always going to put my negative on a fraction with my numerator. All right, now driving directions for this. -1 tells me to go down. +4 tells me to go to the right. Okay, so I'm going to plot 0, -2. Make a nice big fat point there. And then from there, I'm going to go down 1 to the right 4. Down 1 to the right 4. And again, I'm going to do as many of those as I need to. I'll probably go up 1 to the right 4 as I need to make a really good line. Now if you look back, after I graphed both of these equations, I am going to identify where they cross. And it's pretty clear that they cross right there at the point 4, -3. So now I have to check using algebra to see if that point 4 and -3 actually is a solution to this system. So I'm going to use my first equation and I'm going to replace the y and the x with 4, or -3 and 4. And as we can see on the first equation, when I put -3 as y and 4 as x, and I solved it, I got -3 equals -3. Woohoo! So it is a solution to that equation. Now let's try it on our second equation. And as we can see on this second equation, when I replaced y with -3 and x with 4, and I put it as 4 over 1 so you could see my work, that -3 equals -3. So the solution to this equation is 4, -3. This is what I want you to do on the next slide. I want you to graph both equations, tell me what you think the solution is, and then check it using algebra. All right, so on the next one, I want you to graph y equals negative 4x plus 9 and y equals negative 1/2 x plus 2, and tell me what the solution is after you have checked it using algebra. Please pause your video and do that now. All right, check your graph against mine. Check your solution against mine. If you got the correct answer, and make sure you have written all of this in your notes because your teacher is going to want to check them. Now that you know how to solve a system by graphing, the reality is that you're very rarely going to have two equations that are already in slope-intercept form. So we're going to go through just a quick example of what happens when you have a system of equations where your equations are not in slope-intercept form. Now again, a system is where you have two or more linear equations with the same variables. And the solution is that xy pair where the two lines of the graphs of the equations intersect. So you're going to graph both equations, but the very first thing that you must do is you must rewrite both equations in slope-intercept form, which is y equals mx plus b. So if it's not, one of the equations is not solved for y, you must solve it for y. Then you're going to estimate your point of intersection and check your solution just like we did in our last homework. Okay, here's an example. I have two equations, 3y minus 2x equals 21, and y plus 3x equals negative 4. I want to graph these two equations, but they are not in slope-intercept form. So the very first thing I have to do is put them in slope-intercept form, which means that I have to solve the equations for y. Now, I could find the x and y intercepts, but when I'm looking at these, I'm not going to get pretty x and y intercepts. So I think the best thing to do is just solve each equation for y. So let's take our first equation here and solve it for y. Now, I know that to solve this for y, I have to get rid of the 3, and I have to get rid of the negative 2x. Well, remember, you always get rid of things that are added or subtracted before you get rid of things that are multiplied and divided. So I'm going to get rid of my minus 2x by using an inverse operation, which is adding. So I'm going to add 2x to both sides of my equal sign. That is going to give me 3y on the left side of my equal sign, and on the right side I cannot add 21 and 2x because one has an x and one doesn't. So I'm always going to write down my variable term first, the term that has the x with it, and then I'm going to say plus 21 because it's a positive 21. Now the next thing I have to get rid of is my 3, and the 3 is being multiplied by y, so I'm going to do the opposite, which is divide. Now, I am going to caution you right now, do not draw one great big line on the right and put a 3 under it. I want you to show me that you are dividing this term by 3 and this term by 3 separately. And the reason I want you to do that is so that we can show how things cancel. These two cancel and you give me y on the right, or the left, which is what I want. Here, I've just got 2/3, so I'm going to write 2/3 x plus, and 21 divided by 3 is 7. So that reduces to 7. So now I can identify I have this equation in slope-intercept form. And I can identify my y-intercept and my slope. But before I do that, let's go to our other equation and let's solve it for y. Now again, remember I want to get y by itself. So I'm going to have to get rid of that 3x. It is being added, so I'm going to do the opposite, which is subtract. I'm taking the whole term, the 3 and the x. And if I do it to one side of the equal sign, I have to do it to the other. So I am going to get y on the left side, which is what I want. I cannot subtract 3x from negative 4 because one term has an x and one does not. So look carefully. I'm going to write down my variable term first, my negative 3x. And then I'm going to write down my minus 4. Now I have solved this equation for y. Now we're right back to what we were yesterday. We can identify our slopes and our y-intercepts. So let's do that. The slope on this, the y-intercept on this equation is 0, negative 4, because remember it's this right here. And my slope is negative 3. I'm going to put that over 1 and give myself some driving directions. So I'm going to go over to my graph now to negative 4 and put a nice big fat point, and then I'm going to go down 3 to the right 1, down 3 to the right 1. Well, I feel like I need more than 3 points, so I'm going to actually go up 3 to the left 1, up 3 to the left 1, because I want to make sure that this graph goes all the way across my coordinate plane here. I'm doing a very good job here. Up, 1, 2, 3 to the right. There, that's better. Okay. Now, let's go to our other equation, which is my y-intercept. Sorry, I'm using the wrong color there. I'm going to use purple on this one. My y-intercept is 0, 7. It's right here. And my slope is 2/3. If I gave myself driving directions, it would be up and to the right. So I'm going to go over here to 7, and I'm going to make a nice big fat point, and I'm going to say up 2 to the right 3. But I'm kind of out of space, so now I'm going to have to go down 2 to the left 3, down 2 to the left 3. I think I've got enough now to make a pretty good line. Now, I can look at my two graphs, and I can say, where do they intersect? And they seem to be intersecting right here at this point. And that point is negative 3, is my x value, and 5 is my y value. So now let's go over and check this algebraically to make sure that this point really is the point of intersection. So I'm going to check this equation, and I'm going to say, instead of my y, I'm going to put 5 plus 3 times, and instead of my x, I'm going to put negative 3. And that should equal negative 4. So let's put it in our calculators and see. This is 5 minus 9, sorry, because negative 3 times 3 is negative 9. Sorry about my clock going off there. And as you can see, I worked that out and got that negative 4 equals negative 4. So now I need to check my other equation. And I am going to say on this one, 3 times, I'm going to take my y value of 5 minus 2 times my x value of negative 3 equals 21. All right, let's see if this is. We have 15. Negative 2 times negative 3 is 6. And 21 equals 21. It does indeed. So my solution is negative 3, 5. All right, now I would like you to go back over this and look and see the very first thing that we did was we solved each equation for y. Then we identified the y-intercept and the slope. We graphed each equation. We estimated where those two lines intersected, and then we checked that x and y value in each equation to make sure it was the solution. I want you to do one independent practice, and then you're ready for your homework. And that would be 38B. All right, so in your notes, I would like you to solve this system by graphing. Please pause your video now. All right, now I need you to compare your answers with mine. Compare how you rewrote your equations, compare your y-intercepts and your slopes, compare your lines, and then checking your work. Did you get the solution for -3? If you did, you're ready to start your homework.